Welcome back, PreCalc. We are finishing up the 2-4 Day 1 note sheet today. And so we left off after finishing number 3. We're on to number 4 now. We're going to be writing the equation of the normal line. So we just did a whole bunch of problems where we had to find, or maybe we only did one, but we did one problem where we had to write the equation of the tangent line. All right, and we had to find the slope and then write the equation in point-slope form. Now we're going to be finding the equation of a normal line. The normal line is a line that is perpendicular to the tangent line. So what we're going to do is we're going to find out what the slope is at the tangent of the tangent line, and then we can find the slope of the normal line, and then we can write the equation of the normal line. So we're going to be going back to Algebra 1 a little bit with perpendicular slopes and point slope form and things like that. Here's the curve. We've got f of x equals 4 minus x squared at x equals 1. Alright, so what we're going to do first of all is just treat it like we're finding the slope of the tangent line. Alright, in order to find the slope of the tangent line, we got to do that difference quotient. The limit as h approaches 0 of f of x plus h minus f of x all over h. And we're doing the limit as h approaches 0. If you want to, you could plug in x plus h into the function. Since it's at x equals 1, you could plug in 1 plus h into the function. So I think we will do that in just a moment. So we've got f of x plus h. So we've got 4 minus x plus h squared. All right, I'll replace the x in a second. Minus f of x. Okay, so we're talking about minus f of x, which would be 4 minus x squared, all over h. And I'm going to replace the x with a 1. So I'm really doing the limit as h approaches 0 of 4 minus, and this is going to become a 1, so it'd be 1 plus h quantity squared minus, and then this becomes 4 minus 1 squared. Well, 4 minus 1 squared is 3. So I've got minus 3 all over h. All right, and I'm going to simplify some more. So I've got the limit as h approaches 0 of 4 minus, if I square this, I'm going to get h squared plus 2h plus 1 minus 3 all over h. Don't forget to distribute the negative. You get the limit as h approaches 0 of 4 minus h squared minus 2h minus 1 minus 3 all over h. These become negative 4, which cancels out with the positive 4, and the other ones get reduced. So we end up with the limit as h approaches 0 of negative h minus 2. And since h is approaching 0, you can replace it with a 0. You get negative 2. So this is the slope of the tangent line. And then if we wanted to write the equation of the tangent line from here, we could, but we don't need to do that. What we're going to do is we need to find the equation of the normal line. So the normal line is perpendicular to the tangent. If you remember, perpendicular slopes are opposite reciprocals. So if the slope of the tangent line is negative 2, the perpendicular slope, the opposite reciprocal, would be 1/2. So this is the slope of the normal line because it's perpendicular. And now we have the slope. We know what x is. X is equal to 1. We got to find the y value, and then we can write the equation. Alright, so if we know that x is equal to 1, plug it in, you're going to get 4 minus 1 squared, the y value is 3. So we know the slope, we know that the point that it goes through is 1 comma 3. That's our x1 and our y1, and this is our m. Plug it into point slope form. Y minus 3 equals 1/2 times x minus x1, x minus 1. And there's the equation of our normal line. Number 5 says find the slope of f of x equals the absolute value of x minus 2 at x equals 1. This one's a little bit tricky. What we're going to end up doing is we're going to rewrite this as a piecewise function so that we don't have to deal with the absolute value function. Just something to kind of remember. If you have something like y equals the absolute value of x, you could graph this thing and it will look like this. Remember, it makes that little V shape. All right, and what you could do is to cut this into two pieces so that it's a piecewise. You could say, this guy, you'll notice the equation of that line would be y equals x. All right, it's got a nice little slope of 1. And then this piece on the left, you'll notice would be y equals negative x because it's got a nice little slope of negative 1. That's what we're going to kind of do here. If you do the absolute value of x minus 2, that's going to move our parabola 2 to the right. Okay, so we have a point here at 2, 0, and we're going to write an equation for the right branch and an equation for the left branch. All right, so it's going to be f of x is equal to, oops, that's a really bad parenthesis. All right, this right branch is going to be x minus 2. All right, it's got a nice positive slope, and it's x minus 2 because 2 minus 2 is 0. So it has to be x minus 2. And that's going to be for x greater than 2. Then the other branch is going to have the negative slope. So it's going to be negative slope times x minus 2. Or another way of thinking of it, it would be negative x plus 2. All right? And that can be for x is less than or equal to 2. Okay, so we've got our two branches. What we need to do is we need to find the slope at x equals 1. All right, so x equals 1 is going to be on this left branch here somewhere. All right, so we're only dealing with this piece here, the left piece, negative x plus 2. What we're going to do to find the slope is we're going to do our lovely little difference quotient. Limit as h approaches 0 of f of x plus h minus f of x all over h. And we're talking about just this branch. So the limit as h approaches 0 of x plus h, so it's going to be negative x plus h plus 2. Okay, so we got that whole thing. Minus, and then f of x, so minus the negative x plus 2, all over h. And we're going to simplify this a little bit. If you distribute, you're going to get the limit as h approaches 0 of negative x minus h plus 2 plus x minus 2 all over h. So let's see, the x's cancel, the 2's cancel, even the h's cancel. You end up with just the limit as h approaches 0 of negative 1, and that has to equal negative 1. So the slope is going to equal negative 1. And we already kind of knew that going in because you can see that there, but we had to show it with our lovely little difference quotient. So there it is. The slope is negative 1. Okay. Last problem. Okay, you're going to have a couple problems like these on the worksheet. In order for a function to have a tangent at a given point, it must be continuous, so no jumps or anything like that. But even if it's continuous, the slope from the left side and the slope from the right side must be the same. Otherwise, there isn't one slope for you to write an equation for the tangent line. All right, an example of where the slope from the left and the slope from the right might not be the same is, let's say that you had kind of like a weird piecewise function. It ended up being continuous, but it looks like this. All right, you can tell that as you approach maybe this point here, from the left side you're going to end up with a negative slope. That is definitely different than the slope here. All right, you can see that these definitely have different slopes on either side of that point, so it would not work out. All right, so they have to have the same slope from the left as it would from the right. And you can see from the left it's negative, and from the right you're going up, that's positive. Definitely different slopes. If that's the case, then there won't be an equation for a tangent at that point. All right. Does the curve have a tangent at the given point? So we have this piecewise here. What we need to do is first of all make sure that it's continuous. All right. We want to make sure that it is continuous. So check for continuity. All right, if you look at the left-hand limit, all right, as we go from the left side, x is less than 0. As we look at that, it's definitely approaching 0. All right, you plug in 0, you get 0. The right-hand limit, All right, as you approach 0 from the right, if you plug in 0 into this branch, you get 0 squared minus 0, that's 0. All right, and if you do f of 0, all right, which would be this bottom branch, you definitely get 0. Since the left-hand limit equals the right-hand limit, which equals f of 0, we know that it's definitely continuous. So we've got that part down. But now we need to figure out what the slopes are from either side. So we need to do the limit as h approaches 0 of this piece, and then we're going to do it with this piece. All right, so we have to find the slopes at both of those pieces. So we're going to do the top one, the limit of f of x plus h minus f of x all over h, and we're going to plug some stuff in. The limit as h approaches 0 of f of x plus h, so this would be negative x plus h, minus f of x, so minus this negative x, all over h. Distribute, you're going to get limit as h approaches 0 of negative x minus h plus x, all over h. And the x's cancel, the h's cancel, you're left with the limit as h approaches 0 of negative 1, which has to be negative 1. So we know that that's the slope for the left branch. Okay, so the slope is negative 1. Now we have to do the same thing and find the slope from the right side. So we're going to do the limit as h approaches 0 of this. So f of x plus h minus f of x all over h. So we're going to do the limit as h approaches 0 of x plus h quantity squared minus x plus h, all right, minus f of x, so this x squared minus x all over h, and we're going to have to do some multiplying. You're going to get x plus h squared, so you're going to get x squared plus 2xh plus h squared, and then we distribute the negative, you got minus x minus h, distribute that negative, you got minus x squared plus x all over h. Alright, and then we gotta cancel some things out. X squareds are gone, the x's are gone, and then some of these h things are going to cancel. So we get the limit as h approaches 0 of 2xh plus h squared minus h all over h. We can definitely reduce those. The limit as sorry, I'm so used to writing x. The limit as h approaches 0 of, reduce that, you're going to get 2x plus h minus 1. Alright, and so it's approaching 0, so we can replace the h with the 0. You're going to get 2x minus 1. Alright, but we're talking about at a point where for this branch we know that x is equal to 0. Okay, we're given that x is equal to 0. So if we plug that in, you're going to get 2 times 0 minus 1. We know it's negative 1. Alright, so the slope for this branch is negative 1. The slope for the other branch is also negative 1. So the question is, does the curve have a tangent at the given point? The answer is yes. Alright, the slope is equal to negative 1 from both sides of 0, 0. Alright, and since we do have one, we could write the equation if we wanted to. We know the x value is 0. Plug it into both, you get 0, 0. So we have our slope, we have our point. You could write it in point slope form if you wanted to. It would be y minus 0 equals negative 1 times x minus 0. Or you could just say y equals negative 1x. Alright, that would be the equation of the tangent line. I don't even know the problem doesn't even ask you for that, but if it did, that's what you would do, is you would just continue it and put it into point slope form. Alright, so that's it for 2-4.